Hi guys, welcome to our third video on EOG Review Expressions and Equations. And Meredith, I will try to talk a little faster so I'm not boring you to death. So let's go ahead and get started. And we're talking about linear equations, y equals mx plus b. So let's get started. We're going to talk about three things with this video for expressions and equations. Solving systems of equations, just solving equations, and then word problems. And we're going to start with solving just regular two-step equations. So this shouldn't need review, but we'll go over it anyway. So when you're solving equations, basically you're undoing operations. So the first thing you want to do is undo addition and subtraction, then multiply or divide and combine like terms. But before you do any of this, you have to make sure that you don't have to, or make sure to see if you have to distribute like in question B. So go ahead and solve questions A and B, and then check back, pause the video, check back, and check your answers. Okay, so we solved 3x minus 6 equals 9. We got x equals 5. And always substitute your number for your variable back in the equation like I did here to see if it works out. So if I plug in 5 here, does 3 times 5 minus 6 equal 9? And the answer is yes, 9 equals 9. That's a little check mark. Here we have to distribute first, distribute out the 3, and then combine like terms, undo addition, undo division, and we get x equals 3. And again, plug in 3 for x here and see if it checks out. Does 2 times 3 plus 3 times the quantity 3 minus 3 equals 6? And it does. 6 equals 6, so that checks out as well. Okay, let's move on to systems of equations. There's 3 ways to solve systems of equations. There is graphing, substitution, and elimination. And we've gone over some of these in our warm-up practice. So when we're graphing these lines, we're going to graph using the slope and the y-intercept. So again, pause the video, graph these lines using the slope and the y-intercept, and then we're looking for where these lines intersect. So again, pause the video and check back with your answer on graphing systems of equations. Both these lines using the slope and the y-intercept. This y equals negative 3x plus 2 has a negative slope, so it has to go downhill, and y equals x minus 6 has a positive slope, so it goes uphill. So we're looking for the point of intersection of those graphs, and the point of intersection is right here. It is at the point, in this case, it is 2, negative 4. So our solution to this system of equations is 2, negative 4. So how can we make sure that works? Just plug it back in. If I plug in 2 for x and negative 4 for y, it should work in both equations. So in the first equation, if I plug in negative 4 for y and 2 for x, I should get the same thing on both sides of the equal sign, and I get negative 4 over here, and negative 6 plus 2 is equal to negative 4. Same thing if I want to check with the second equation, plug in negative 4 for y, and negative 4 is equal to 2 plus negative 6, and that also works. So we know our solution, which is right here, this point right here, that is a solution to this systems of equations, and it's the only solution that works. But also keep in mind, we do have systems of equations that have no solution, which are parallel lines, and systems of equations which have infinite solutions, which turn out to be the same line. So let's go ahead and move on to substitution. Substitution just means replacing y or x with a different variable, and well, the only variables we have are y and x. So we have to ask ourselves, is y equal to y? And the answer is yes. Now you can graph these on the coordinate grid like we did up above and find the intersection, but we can also solve it using substitution. So if y equals y, we can say that the first y, which is 4x plus 2, is equal to x minus 1. And then we're just going to go ahead and solve it like a multi-step equation. There's my river. I'm going to subtract 2 from each side. That's going to cancel. Subtract x. And we get 3x equals negative 3. So the x coordinate of our solution is negative 1. So far, our solution to this system is -1. Well, we don't have an ordered pair yet, so now we need to find y. And I can pick either equation, and I'm going to pick x minus 1, so y equals x minus 1. We're going to take out x, and we're going to plug in -1, and y equals -1 minus 1, so y equals -2, and that is the y value to our solution. And again, we can plug it into both of these equations. If I do 4 times -1, that gives me -4, and -4 plus 2 is -2. And then obviously it works for this one because that's where we got our solution of -2. Next one is elimination, and elimination just means to get rid of either the x or the y variable and then solve for the other one. And again, we did this one on a warm-up just recently. So we have to look at the coefficients of x and the coefficients of y, and we need to change them so that they're the same. So we can either eliminate the x variable or we can eliminate the y variable. I'm going to go ahead and I'm going to eliminate the x. So I need to find the LCM of 4 and 5. And the least common multiple of 4 and 5 is 20. So I'm going to multiply this top equation by 5 to get my x value to 20, and the bottom equation by 4 to get my x value by 20. I'm going to go ahead and pause the video and then multiply those out, and let's see what we get for new equations. So when we multiply it out, we end up with 20x plus 15y equals -5. Remember that 5 needs to get multiplied by everything inside the parentheses, and same thing with 4. So now we can either add or subtract these, but if we add these two together, we're not going to eliminate anything, so we're going to subtract. And you could have just multiplied this one by a -4. 20 minus 20 gives us 0. 15 minus 16 gives us -1y. And then -5 minus 4 is going to give us a -9. So divide each side by -1, and for our y value we get 9. So for our solution, we have a y value of 9. So now we need to go back and find x. So pick an equation. I'm going to pick this one right here. So I have 4x plus 3y equals -1, and that's 3 times 9 equals -1. So 4x plus 27 equals -1. Subtract 27 from each side, we get -28. Divide by 4, and for our x value we get -7. And whether we choose the first equation or the second equation, we would still get x equals -7 for our x value of our solution. So our solution to this system using elimination is -7 and 9. And finally, we are going to move on to word problems. This, I believe, in our Math 1 unit was where we had the mixture problems, but these are a bit easier. So this is the important part. Define your variables, then set up the system and solve. But I'm going to stress again, this is the important part, define your variables. So it's asking us here to find the value of two numbers if their sum is 12 and their difference is 4. So we have two numbers, and since it's a system of equations, we're going to let x equal the first number. And equations, our linear equations just have x and y is the second number. So the sum of the two numbers is 12. So the sum of x plus y equals 12. Second part of that, their difference is 4. So x minus y equals 4. So now we go back to our 3 ways for solving systems. We can graph, substitute, or eliminate, and this one is set up beautifully for elimination because if we add these two, we can just get rid of the y's. X plus x is going to give us 2x. These two are going to cancel, and 12 plus 4 is 16. Divide by 2, and we get x equals 8. So we know that our first number is equal to 8. So now we have to find our second number, so now we need to find y. So pick an equation. I'm going to pick x plus y equals 12. Doesn't matter which one you pick. I'm going to plug in 8 for x. So 8 plus y equals 12. Subtract 8 from each side and we get y equals 4. So our second number is 4. So our answer would be the two numbers are 8 and 4. So try the second word problem by yourself, pause the video, and then check back for the answer. Okay, so I've set up the equations for you. Our variables are x and y. X is a fancy shirt, y is a plain shirt. So the first part of the word problem says she spent $131 on shirts. So this equation talks about our cost, and this equation talks about our total number of shirts. So fancy shirt is $28, plain shirt is $15, and that total is $131. For a total of shirts is x plus y equals 7. So at this point you have a couple options. You can use elimination or you can use substitution. And in my opinion, I think substitution is the easiest way to go with this one. So what I would do is I would solve this second equation for either x or y. And if I solve for x, I get x equals 7 minus y. And I can take this x equals 7 minus y, this part of the equation, and I can plug it in for x right here. So if I do that, I get 131 equals 28 times 7 minus y plus 15y. 131. So I distribute the 28 to the 7 into the minus y, and then 7 times 28, 7 times 8 is 56, 7 times 2 is 140, is 14, so 196. So we get 196 minus 28y plus 15y. So same thing, 131 equals 196. We're going to combine like terms, and that's going to give us a negative 13y. Subtract 196 from each side, and 131 minus 196 is 65. Divide each side by 13, negative 13, so negative 65, sorry, by negative 13. They're going to cancel, and we get y equals 5. And so 5 is the 5 plain shirts. So if we know that y equals 5, we can go back and use this equation right here to figure out what x is. So if y is 5, then x has to be equal to 2 fancy shirts, and x equals 2. So it's a total of 7 shirts with a total cost of $131. Okay, moving on. So there are 6 questions with systems of equations and solving equations, 1, 2, and 3. What are the solutions to the systems? So keep in mind, and I'm not sure, some of us may have made a foldable on this, if they're both in y equals form, the easiest way is to graph it. If they're in standard form, first look to see can you add or subtract these systems to eliminate either the x or the y. And if you can't, then you might want to find a common, least common multiple, but this one's set up pretty easy. And this is one where you might have to change little things. You can if you want, and some people like to change these all into y equals, but this is a good one that's set up for substitution. And in my opinion, on this one, I would solve for x on this one, and I would get x equals negative 3y, and then I would take out x and plug that in. And then 4, 5, and 6, 2 word problems, and the number 6 is just solving a multi-step equation. Okay, if you have questions, keep in mind that next week we will have smart block sessions for each of these domains and I'll post those on the board. Have a good night.